Hello, am I audible?
Yes, sir, you're audible, sir.
Okay, fine, thanks. Okay, so is there any doubt from week 9 which you want me to discuss?
Sir, Riemann sum, sir. That's kind of confusing.
Sir, I have doubt in practice section.
Yeah. Okay, so just give me a minute. Okay, so what is the confusion? Like, can you tell me from Riemann sum, like which?
Sir, the thing is, whenever we are taking some intervals, like is it totally up to us? Like, how many intervals do we want to take while calculation, or it is like some fixed? Because I think it's not like that. It's like it's totally up to us how much like how many intervals we're gonna take to divide the segments, like the area under, like, to calculate the area under curve. But sometimes it's like very confusing. Like let's say we have an interval from 2 to 8. So I can take one interval, I can take 4 intervals, I can take even 6 intervals, even I can take 8, 10 intervals. So this is the confusion. So as I totally understand the concept that as many intervals are there, the answer would not be approximate, like it would be very close to the actual value. But still, what should be the, like, any a general, like a standard not notation, a standard viewpoint from our side when we take the segment division or something? So that's the thing, sir.
Okay, just not sure. Like, okay, let me try to explain it. So,
sir, how many weeks will come in quiz 2?
This is basically from week 1 to week 8. Again, like since some of the things from basically from week 5 to week 8 are related to some of the things from week 1 to 4. So that's why actually we're saying from week 1 to 8. But again, like most of the things, certainly it will come from 5 to 8. Okay.
Sir, what will be the weightage of week 5 to 8?
So I don't. Okay, so regarding the weightage, okay. See, so the thing is, I certainly am not going to announce it in session. If I have to do, then certainly I will send you an announcement through mail. Okay.
So how can I got your mail?
We'll send you announcement, right? If
there is a message regarding to the weightage, then you will send
through announcement, email or announcement, whatever. Like I'll basically will send to all the students. Okay, so okay, so Sayan, are you here?
Yes, sir.
Yeah. Okay, so let me take. So suppose you have a function. Okay, so let's say this is my function. Let's say this is my function, right? So okay, so before that, okay, so let me quickly recall. So what is basically Riemann sum with respect to a partition of an interval? Okay, so suppose you have suppose you have some interval, let's say a comma b, right? Suppose you have an interval a comma b, and so suppose for this interval I have a partition. Let's say this is my partition. Okay, so I guess should be xn, which is equals to b. So the Riemann sum is basically with respect to, so for it, so Riemann sum with respect to this for this function. So f is a function from, let's say, a comma b to r. So the Riemann sum of f with respect to this interval, Riemann sum
A to n f of xi star into delta xi.
into delta xi, and certainly star is basically it's a choice. So it's this choice is up to you. Okay, choice of xi star is a choice, like you can pick any number in between from this interval, right?
Sir, I have a doubt in this point. So we take any point between this interval, like left hand side or right hand side or the middle value, whatever may be. But
Yeah.
on lecturer, they are telling the area of triangle is converted into area of a trapezium, I think. So for that one, they are choosing f of xi and f of xi minus 1. So I have a confusion in what is the xi on that value. That means what is the width, I think. So I have a little confusion in that area of a trapezium. Yes, sir.
Yeah, so okay, so let me come to that. Okay, so before that, I'll come to that. Okay,
Okay, sir. Okay, no problem.
So so it's this choice is basically it's up to you. Okay, right? So this choice is basically up to you. Okay, so so suppose you want to compute this. Suppose this is my function, right? This is my function, and you want to compute this area of this function. Let's say this is my 1 and this is my 2. This is my, let's say 3. And so initially what you do, you take one partition. Let's say your partition is basically so the interval a comma so this now this interval a b is nothing but it's basically 1 3, right? So this is 1 3. Okay, so now you take a partition. So what is your partition? Let's say your partition is 1 2 3, right? Let's say this is your partition. Okay, so if I take a partition, right? So if I take a partition, so the middle point, so basically I have a middle point over here. This is basically 2, right? Correct or not?
Yes.
So in that case,
Yes, sir. Yes, sir. Yes, sir.
So basically I have 2 intervals, right? So in that case, I have 2 intervals, 1 comma 2 and 2 comma 3,
2,3.
right?
Yes.
Yes, sir.
So I can find my Riemann sum with respect to this partition, but for that I have to need I need this xi star. So I need to choose some xi star from this interval and as well as this interval, right? So once I choose this interval, then suppose for this interval, this so let's say x1 star is what? X1 star is what? Let's say this is half. Not sorry, half. This is 3 by 2, right? And x2 star is basically 5 by 2.
5 by 2. Okay.
Okay. So this is my choice. So it's not like, so suppose I am taking 3 by 2, you can take, instead of 3 by 2, you can take 1 and 5 by 2. That is also fine. Like, so it's certainly this Riemann sum is complete, also depend on this xi star. Okay, so so suppose I am taking xi1 star to be 3 by 2. So with respect to this partition and with respect to this xi star, my Riemann sum is basically what? My Riemann sum is what? F of 3 by 2 times the length of interval. What is that length of interval? 1.
So 1.
And similarly, f of 5 by 2?
5 by 2, 1.
The length of the interval. Okay. So that means basically what is this? So try to understand what this thing actually represent. Okay. This thing, what this thing basically represent.
Area
So,
of triangle. Rectangle.
Area of rectangle. So what is that? What
Area
is
of
that?
rectangle.
Yeah. So what is that rectangle? So if I take this point, let's say 3 by 2. So this 3 by 2, right? let's say this is my point 3 by 2, right? So this height is basically this height, whatever this height, this is basically f of 3 by 2, right? This height is f of 3 by 2.
Yes, sir.
Yes,
so,
sir.
so this term f of 3 by 2 times 1 is nothing but it's basically this area of this rectangle, right? This is basically area of this rectangle, right? And similarly,
Yes, sir.
if I take this thing, then similarly with the same argument, I can say that, let's say this is my, okay, so if you have some question, then please directly ask me, okay? You don't have to raise your hand. So similarly, this particular thing, this f of 5 by 2 times 1, this basically, this is my f 5 by 2, and this sum is basically this area of this rectangle. Okay, let me probably use some different. So this area of this rectangle is basically this thing. Okay, right? So with respect to,
Yes, sir.
again, as I said, so as you can see, this whatever I am getting, it's not giving me the exact area, right? Because as you can see, I have some extra part here, right? This part actually, which I don't want, this part, this yellow part, actually I'm getting some extra thing, okay, which is not included in my area. Okay, I'm getting some extra thing, right? So, okay, yeah, so this yellow part, actually I'm getting few extra thing. Okay, so with respect to, again, like with respect to this partition, actually this is my Riemann sum. Okay, this is not my area of the curve. This is a approximation value of the area of the curve. Okay, so this, whatever this thing is, this is actually, it's a approximation to the area. Okay, this is a approximation to the area. Right? So again, so suppose again, if I take some better partition, like if I, so here, as you can see, I have taken basically some 2 partition. Okay, so for 1,3, I have taken this partition, and another one is, so basically I'm getting 2 intervals. Okay, so whatever partition I took, from there I'm getting basically 2 intervals. So instead of that, if I increase my partition, okay, so let's say if I increase my partition, let's say I increase my partition. Okay, okay, suppose I increase my partition, right? So this is my 1, this is my 3, right? Let's say I take 1, and then let's say this is my so my partition is 1, 3 by 2, 2, 5 by 2, and 3, right? This is my new partition. So from here, actually what I'm getting, so I'm getting for let's say 1,
1 to 3 by 2.
3 by 2, then
3 by 2.
3 by 2 to 2,
2 to 5 by 2, and 5 by 2 to 3.
right? This is my new, so these are the interval which I'm getting after from this new partition. Okay, so this is 3 by 2. Let's say this is 3 by 2. This is let's say 2, and this is my 5 by 2, right? So now what I will do now, so I'll try to find let's say some Riemann sum with respect to this partition. So for that, again, I have to make a choice of xi star. Okay, so let's say what is xi star for this interval? let's pick some xi star. In the maybe in the similar fashion, what I will get if I take take the midpoint of this interval, what I will get? What is x1 star here? Can you tell me? What is the average of these two?
5 by 4.
0.5, I guess. Half.
No.
3 by 2 minus 1.
5 by 4.
5 by 4.
What is this?
5 by 4.
5 by
4.
5 by 4. Okay. So what is for then? What is x2 star?
7 by
7
4.
by 4. 9 by 4.
And this is x3 star.
11 by 4. Next one.
Yes, you are saying this is 11 by 4. Right? So now, okay. So now what is basically, so if I apply this, then if I try to find the Riemann sum with respect to this given interval and where this xi star are this, okay. So then my Riemann sum is basically what? F of 5 by 4 times the length of the interval, which is half, right? And plus f of 7 by 4 times the length of the interval half. So f of 9 by 4 times the length of the interval half. F of 11 by 4 times the length of the interval half. Okay. So again, like as you can see, this thing, whatever it is,
Sir,
yeah.
before f of 9 by 4 and 11 by 4 addition, sir, you put multiplication on that.
Okay, so this, whatever this thing is, this basically represent this
Area of triangle.
area of this rectangle, right? So you say, let's say this point is, this is, let's say 3 by 4 by 5 by 4, comma f of 5 by 4. Then this is basically the height, right? This height is basically what? This height is f of 5 by 4. And this term, whatever this term is, f of 5 by 4 times half, this is basically area of this rectangle. Okay, area of this rectangle. Okay, area of this rectangle. Okay, and similarly, if I take the next one, f of 7 by 4 times half, okay, f of 7 by 4 times half. So then I have 7 by 4 here, okay, and this height is basically f of 7 by 4, and this, whatever the next thing I will get, this is basically f of 7 by 4 times half, this thing. Okay, and similarly, what is my next thing? The next thing is f of 9 by 4, right? So it will come in the middle. Okay. So this is my f of 9 by 4, and this is my area. Okay, this term basically represent this thing basically represent the area of this rectangle. Okay, this rectangle. And similarly, if I take f of 11 by 4 times half, this basically represent area of this rectangle. So the thing is what actually, so if I increase this this number of partition, then actually, as you can see, actually we are getting a better and better approximation to the area, right?
Yes, sir.
So as you can see here, the error is error is pretty less. Okay, so here the error is pretty less. So basically, so when actually to increase the number of partition, actually what we need to do, we need to reduce the length of the interval, right?
Yes, sir.
So basically,
sir.
if the length of the interval will go towards 0, right?
Hmm.
If the length of the interval will go towards 0, then we'll get the best partition, right?
Yes, sir.
So with
Yes, sir.
respect, so for that base partition, actually we'll get the exact area under the curve. Okay, so that is actually the main idea. Okay, so if you increase the partition, as you can see, again, this whole thing is a approximation to the area. It's not the exact area. Okay, but again, if I increase my partition, then I will get a better so if I increase the number of partition, that means if I reduce the length of interval, then I will get some better approximation to the area. Okay, so once this length of this partition will go towards towards 0, that means you are actually in some sense you are taking the best partition. So with respect to that best partition, you will get the exact area. Okay, so that is the idea of this Riemann sum. Okay, again, whatever we are doing, this is basically Riemann sum with respect to the given partition. This is the Riemann sum with respect to the given partition. Certainly, this is not equal to the exact area under this curve. Okay, this is the approximation area. But once you take this partition, the length of the partition towards 0, then definitely you will get the exact area. Is it clear?
Yes,
now?
sir. Yes, sir.
Yes, sir.
Yes, sir.
This
Yes,
is
sir.
clear, sir.
What's
Could you explain with the trapezium also, sir? Because I can clearly get it what the trapezium plays the role.
No. So the thing is actually, so again, like, so the thing is, okay, I'm getting some noise. Can you, okay, so the thing is, what actually we are doing here, we are trying to manipulate the area, okay,
Yes,
using what? Using rectangle, right?
yes, sir.
So instead of rectangle, okay, you can similarly you can try to approximate the area using trapezium as well. Okay, but the thing is, okay, but the thing is, why actually trapezium? It's not something not nice way to do it. Okay, so basically computing the area of rectangle is much more easier, right? So computing the area of a rectangle is basically much more easier. Okay, so if you try to do it using the rectangle, so there is nothing special about rectangle. Similarly, if you can try to compute the area by giving some triangle also, but again, computing the area of a triangle is difficult, right?
Yes, sir.
So compared to the so what actually you will do, suppose this is your, let's say this is your graph. Okay, this is your graph, and you want to compute the area of, let's say, this interval. Okay, so instead of putting a rectangle here, so what we are doing actually, we are putting rectangle, right? We are putting rectangle and we are computing this. Okay, so instead of rectangle, what you will do, you have to put, if you put, let's say, triangle. Okay, let's say this is my triangle, you fill another triangle here, you fill another triangle here, triangle here. So in this case, this is very complicated, right? So let's say this is your triangle. First you take this triangle, okay, then let's say you take another triangle here, and you try to fill this place using lot of triangle. But computing this area of this triangle is difficult, whereas computing this area of this rectangle is very easy. Okay, so similarly, so again, there is nothing special about this rectangle. So you can also use this trapezoidal, okay, to basically compute the area. Okay.
Yes, sir, I can understand, but on that lecture, our professor tells that trapezium is getting more closer than rectangles because they are telling that the 2 points on the trapezium
Hmm.
on that curve,
Hmm.
like f of xi and f of xi plus 1, it's like how we tell. It's more suitable on that curve. If it's rectangle, there is some gap between.
Yeah. Correct. Again, like certainly, as I said, you can you can certainly get a better approximation. Okay, just a minute. Okay. So basically, tell me how actually you compute this using this trapezoidal rule. How you compute first step. So this is, let's say this is your graph, right?
Yes, sir.
Let's say this is your x1, right?
Yes, sir.
And this is, let's say, your x2, right?
Yes.
So if you apply trapezoidal rule, then what you will get?
Sir, more or like same to rectangles because we are just calculating the areas and sir, but I have a doubt in that 2 points on that curve, sir. So on that 2 points, how I calculate the area? That's the basic doubt, sir.
Under this 2 point, in the sense, I didn't get.
That means if it's let us assume this interval is broken into 2 parts. So x1 plus x2 divided by 2, that's the middle point.
Let's say this is your point A.
Okay. Point A. So I have a 2 trapezium. So first point on the trapezium, let us assume x1a, that trapezium. So f of x1 is that point on that curve, and f of a is that point on that curve. If I connect this,
then basically, let's say this you connect, right?
Yes, sir.
And similarly, you connect this, right?
Yes, sir.
So the thing is, what is the area of this part? What is the area of this part?
Then we apply the rule like half into height of that.
Yeah. So what is the area basically?
Half into height of that side into the sum of the parallel sides.
Half into,
I think f of x. Actually, that's the doubt, sir. What is the height of this one? Because
this
f of x1 is.
This is basically so
A
what is
minus x1.
So what is this? This is f of x1, right?
Yes, sir.
And what is this one?
This is f of a.
What is the area of trapezoidal?
So half into height is nothing but a minus x1, I think, sir.
Sorry?
So the height of the trapezium is a minus x1.
Correct. Right? So,
yes,
so the area is basically this area of this trapezoidal is nothing but height times
sum of its parallel sides.
Half into sum of its parallel sides.
Yes, sir.
So this is, so height is basically, the length of the interval is basically will give you the height.
Yes, sir.
Right. So that is basically what is the length of the interval. So length of the interval is x1, sorry, not
a minus x1.
A minus x1, right?
Yes, sir.
And this side, so these two sides are parallel side, right?
Yes,
this
sir.
one
So
and this one.
So f of x1 plus f of a divided by 2.
F of x1 plus f of a divided by
2.
2, right? So this is area of this trapezoidal, right?
Yes, sir.
Yeah. So trapezium. Okay. So again, I have taken two intervals, right? This partition basically will give me 2 intervals. Okay. Again, similarly, I can compute
this one too.
This one also. Okay. So again, similarly, I can apply the same rule, x2 minus a, right? Times what? This is my f of x2, right?
Yes, sir.
So this is
f of x2 plus f. Okay, f of x2 divided by 2.
Okay. So again, like as I said, there is nothing special about this rectangle. Okay. So you can apply the same trick over here. Again, this you have taken one partition, right? Basically, this partition will give you 2 intervals. Okay. So similarly, what you can do, you can make some finer partition. That means you
Yes,
can take some 3 partition. Okay, let's say this is your core and this is x1, and let's say this is x2, and you take this is your point A and another partition, right? So again, what you have to do, you take this trapezoidal. Okay, so you take this one, okay, and again you take this one, right? Okay, and again you take this one. Okay,
yes, sir.
so again same thing will happen if you
Yes,
increase
sir.
the partition. Okay, so then again you will get a better up. See, you apply the same
Yes,
trapezoidal rule.
Yes, sir.
Okay, you apply the same trapezoidal rule again by using the same logic. If you increase the partition, okay, number of partition, that means the length of the partition is going towards 0. So then you will get the best approximation to the area. Okay, whatever
Okay, sir.
we are doing for rectangle. Okay, so you need to apply the same rule for trapezoidal as well.
Hmm.
Okay.
Okay, sir.
So here actually, as I said, here it's pretty easy. You can directly apply this the product of length into width, right? So here, but here you have to apply slightly different rule. Okay, you just need to. So this is your height, which is basically the length of the interval, and instead of taking the difference, the height, what you are actually taking the sum of the two length of the two parallel side divided by 2, right?
Yes,
So,
sir.
so that is the thing. So again, like if you so as you can see, like finding this trapezoidal sum is slightly complicated than this one, right?
Yes, sir.
So but again, certainly if you can do it, then you will get the answer. Okay, if you take some partition, so if you decrease the length of your partition, okay, that means the length of the partition is going towards 0. And if you find the trapezoidal sum, then obviously this will also give you the area under this curve.
Okay, sir.
Sir, but trapezoidal sum is more precise than rectangular sum.
Sorry?
Trapezoidal sum is more precise than rectangular sum.
Yeah, in some sense, like maybe probably in some curve, I'm not sure. I have to see, but okay, for this type of curve, I can easily say that this trapezoidal rule, trapezoidal sum will give you a better approximation to the area compared to this rectangular sum. Okay.
But sir, still we use rectangular sum.
No,
Just
so the thing is, okay, if you take your, so as I said, like, so basically I said, right, finding this rectangular sum is easier, right? Finding this rectangular sum is easier or not?
yeah, sir, it is easier, but we
Yeah.
are tending to get more precise area.
Yeah, no, but again, like if when n is going, when this length of this partition, okay, length of this partition is going towards 0, then both of the things will give you the same value.
Yes,
Okay.
sir.
Means trapezoidal sum and rectangular sum will give same area when we increase the number of partition.
Yeah, when this length of the partition, okay, this length,
Tends
okay,
to
this
0.
length, when this length of this partition is going towards 0, okay, eventually you will get the same result. Okay, but if you are taking some fewer partition, let's say some 3 partition, okay, for this curve, okay, for the same curve, let's say you are not taking a partition where this, you are not taking some partition where this length of the curve is, length of the interval is going towards 0. But if you are taking some 3 partition, okay, in this case, if you take this trapezoidal sum, then certainly this will give you a better approximation to the area instead of rectangular. Is it clear now?
Yes, sir. Clear.
Yes, sir.
Yeah.
Excuse
So,
me, sir. Sir, can you please explain what is left hand Riemann sum and right hand Riemann sum?
Yeah. So okay, so this is more or less same. Like nothing special about this. So
And
this,
also, sir, if it is not given that there is a left hand remand or right hand remand, then what we will implement?
no,
What
no,
we
no,
will
no.
assume?
No. So if nothing is given, then you take any Riemann sum. Okay, this Riemann sum, this xi star, you can take anything. Okay, this xi star. Okay, this is a choice from this interval, right? You can take anything from that interval. Okay, so if the so the thing is, if it is left hand Riemann sum, okay, see this xi star. Okay, so this xi star has to be equals to x I minus. Okay. And if it is right hand Riemann sum, then this x I star should be equals to xi. Okay. So that is actually the difference between left hand Riemann sum and right hand Riemann sum. So in
Okay, sir.
Riemann sum, when only the way Professor Sarang defined the Riemann sum, this xi star can be anything from this interval, right? This xi star can
Yes,
be anything from the interval. But when you are considering left hand Riemann sum, this xi star has to be equals to xi minus 1. Okay. And when you are considering right hand Riemann sum, this xi star has to be xi. Clear? I'll do some example, but the idea is clear or not? What is the meaning of left hand Riemann sum and right hand Riemann sum?
yes, sir.
Sir, that related question is given in activity 4, question number 10.
9.4, question number 10, right?
Yes.
Sir, I have a doubt in one small concept, sir.
Tell me.
Yes, sir. Actually, my doubt is one of the question in activity question 9.1, question number 7, it's related to the derivative of that function. So based on the derivative of the function, how
9
we
point, can you repeat?
activity 9.1, question number 7, sir.
9.1,
Yes, sir.
that is maximum minima, right?
Yes, sir. Maximum minimum.
Question number 7, I'll come to that. Okay, so okay, just let me finish this integration part, then I'll come to that. Just
Yes.
someone said some question related to
Yes,
left.
sir. 9.4, question number 10.
9.4, question number 10. Yeah, that is slightly different question. Okay, this is certainly not related to left hand Riemann sum and
Sir,
right hand
Sir,
Riemann
we
sum.
have to find the absolute value, absolute difference between left hand and right hand Riemann sum.
Yeah. So for that, I have to compute the left hand Riemann sum and right hand Riemann sum, right?
Sir, can you explain that question 8, 9, 10,
Yeah,
9.4?
just a minute. Okay. Yeah. Okay, so I'll come to that. Just give me just let me take some basic example, then I'll come to this general.
Yes.
General. Okay, so suppose let's say this is my function x square, right? And so let's say this is defined on this interval 0 to let's say 4, right? So so the with respect to, and let's say the partition of this interval, let's say the partition of this interval is what? The partition, one of the partition is 0, 1, 2, 3, 4, right? So once I have this partition, then how many intervals this partition will give me?
4 into
0 to 1, 1 to 2, 2, 3, 3 to 4.
And 3 to 4, right? So basically this, so I have basically 4 intervals, right? So now actually I want to compute my left hand Riemann sum. Okay, first I will compute my left hand Riemann sum. Okay, so again, like as I said, so when I'm computing the left hand Riemann sum, then what is my xi star here?
0,
Because I
Zero,
have,
sir. X
yeah,
zero.
yeah,
0.
correct. So x1 star is basically 0. That is basically the left side of the of this interval. Okay, and similarly this x2 star is 1. Okay,
X3 star is 2.
2, and x4 star is 3.
3.
So once you fix this, once you know the intervals, and once you know this xi star, then basically the rest of the thing is basically addition and multiplication. Okay, so then my final Riemann sum is basically summation of x. So my Riemann sum with respect to left hand Riemann sum with respect to the given data is basically length of del xi, and in here the length of del xi is basically 1,
1.
because this is 1, this is 1, this is 1, and this is 1. So this is, I can write f of xi star, right?
Yes, sir.
So then this is precisely what? F of
F
0.
of 0 plus f of 1 plus f of 2 plus f of 3.
And you can easily evaluate what is f of 0, f of 1, f of 2, f of 3, and you just add it. Okay, whatever final value will get, that is actually the left hand Riemann sum of this function with respect to this partition.
One question here, delta xi will be one, will be true for RH also, right? If the
Sorry?
difference is one.
Sorry.
So this xi different delta xi, right?
So
So that will be one if we take it and differences of one, correct?
yeah, that is, this difference is 1, right? For
Correct.
this interval, this difference is 1.
So
So
for
hmm.
RH also it will remain same. What I meant, delta xi will always be one for RH also, correct?
right hand Riemann sum, you're saying.
Yeah.
Yeah, because if I take the same interval, then
Correct.
certainly it will not change the length of the interval.
Yeah.
Only
right?
xi star will change.
So only xi star will change. So for right hand Riemann sum, then for the first interval, what will be my x1 star?
1.
1.
This is basically the right hand side of my interval. Okay, and similarly x2 star is 2, x3 star is 3,
3
and x4
and
star
4.
is 4. And finally, if you compute, then basically what you will get, f of 1 plus f of 2 plus f of 3 plus f of 4. So this is your right hand Riemann sum. You substitute and you can get your answer. Okay. Okay. Yeah. So this clear, right? This how actually, for at least for this function, how we are getting this left hand Riemann sum and right hand. Okay, please mute yours. Yeah. Okay, so someone asked some question 9.3.
Sir, sir 9.4.
9.4, yeah. 9.4, question number 8, right?
8, 9, 10. That they are related.
Yeah, they are related. Yeah. Let me do some. Yes, there are so many things in option 8. Okay, I'm certainly I'm not going to do all. So
Sir, we are seeing your screen.
sorry.
Sir, we are seeing your both screens, sir. We are not seeing the activity. Sir, are you present the activity questions?
Yeah. Just a minute. Okay.
sir.
Okay. Again, like please mute yourself. I'm getting some TV sound or something. This one, right? You can see my screen, right?
Yes.
Hello? This question, right? You are asking this.
Yes, sir, it's visible.
Yeah. Yeah, so yeah, so basically, what is your function over here? So your function is f of x equal to x, right? This is your identity function, and what you are taking. So and again, this my interval is 0 to 5. This is my interval 0 to 5 closed interval, and I am taking some partition. So what is my partition? So my partition is basically what? 0. So this is 0, 5 by n, right? Then I guess, sorry, 2 5 by n, and my ith term basically it's basically 5 times I
A by n.
n, and this goes up to my basically my nth partition, that is the last partition is basically 5. So this is my xn, this is my 0, right? This is my partition. Correct or not? Am I making any mistake? Xi is I times 5 by 5. Yeah, correct. Okay, so this is my partition. So now tell me, what is del of xi? So what is del of xi?
5 by n, sir.
Del of, so as you can see, so my interval are basically so this is xi minus 1 and xi, right?
Yes, sir.
And what is xi minus 1? Xi minus 1 is basically 5 times I minus 1
Minus 1 by n.
n, and this is 5 times
I by n.
I by n. And if I take the difference, so what is del of
Xi minus xi minus 1.
xi minus 1. So if you take the difference between two things, then probably then precisely you will get 5 by n, right?
5 by n. Yes, sir.
Yeah. So now let me compute the first option. The first option says if xi star
Equal
is
to xi.
is xi, then the Riemann sum is whatever, right? Let's say with respect to this all this interval, let's say xi star is my xi star is, so xi star is what?
5 I by n.
Xi, right?
Yes, sir.
So xi star is basically what? Xi star is a member of what? Xi minus 1 xi. But here in this case, actually we are taking xi star to be this thing, right?
Right hand side.
So that means we are computing what? Right hand
Right hand.
Right.
Yes.
right hand Riemann sum.
Riemann sum.
So we are computing right hand Riemann sum. Okay, so for that, what actually we have to do? We have to take summation f of
Xi star
star
into 5 by n.
del of xi, right?
Hmm.
And what I will get? So this is basically what?
F of 5 I by n.
Yeah, so f of x, yeah, times f of xi star times 5 by n, right?
Yes, sir.
So from where to where I have to take this
I equal to 1 to n.
1 to
n.
n, right?
Yes, sir.
So now this is more or less easy to n. what is f of xi star? F of xi star is precisely f of xi, right?
Yes, sir.
Times 5 by n. And what is, we have computed, what is f of xi? What is the general form of f of xi? F of xi, sorry, what is xi? So xi is
Xi
this.
is pi I by n, sir.
And if I substitute, if I compute f of xi, then I will get
No.
precisely xi, right?
So, yes, sir. So pi I by n.
So this is 5 times I
Pi
by n,
into 5n.
5 by n, right?
Hmm.
And what I will get if I, so
25
25 by n square, right?
summation. Yes, sir.
Summation
Summation I equal to 1 to n, 1 by n.
n, sorry,
Sorry, I.
So now what actually we are getting 25 by
N
n
square.
square,
N into n plus 1 by 2.
correct. So this is basically 1 plus 2 plus 3 dot 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 up to
Sum till n.
n. So this is nothing but 25 by n square,
N into n plus 1 by 2.
n into n plus 1.
By 2. So we cancel out the n and n's.
Yeah, what, like, yeah, you can cancel, let's say this n, right?
Yes, sir. We will get 25 times n plus 1 divided by 2n.
55 times n plus 1 divided by 2, right? So yeah, so basically with respect to this given data, the right hand Riemann sum is precisely this. So this part is clear.
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
again, like certainly I'm not going to do for
Same logic.
Yes, sir.
A.
Understood.
all the option. So
Yes.
which option you want me to do in question number 8? I have done probably option number 1.
Sir, I understood. Not required.
Yeah.
Thank you.
Sir, I have a doubt in same concept, sir. Active 9.5 question number. Question number 7 and 8, they are related to Riemann sum, but only they are telling which following option is correct, but there is no question before that option, sir. So
Yeah, so are you a qualified student?
sir, yes, sir.
Yeah. So basically, I was right checking the portal from now itself. I actually came to know that there is a problem with the qualified portal. Okay, it's correct in term portal. Okay, so if possible, you can take a screenshot. Okay.
Yes, sir. That's
So this is actually precisely the thing that actually you are missing in qualified.
yes, sir. This part is missing in my question.
Yeah. So this part is actually missing. I told just now, I told this portal team they'll fix it. Okay. As soon as
So 1 minute, sir. I take a screenshot for this
Yeah,
question. Yes, sir.
Yeah.
Thank you, sir.
Sir, our portal has not been updated. It's still qualifier. That's why we have.
Yeah. So no. Basically, the contents are same. So it's not that we are providing something extra in term portal. Okay. Everything, everything, the contents of qualifier and the term portal, they are basically same. So yeah. So but yeah, in this case, actually, this is this part is missing in qualifier. Okay, so similarly, I guess you can compute the other. Okay. Yeah. So let me go back to thing. Okay. So anything you want me to discuss more about this Riemann sum?
A different question, not Riemann sum. 9.3, 10th question. Actually.
9.3, 10th
10th
question.
question.
Yeah. Okay, 9.3, 10th question is again like this. Okay, this has nothing to do with Riemann sum. Okay, let me do it's more or less, okay, certainly this has something because you compute area and all these things, but okay, it has not directly related to this. So let's say this is, so you have a square, yes, you have a square, right? So let's say this is the square. Let's say this is the square. Okay, so this may look like a rectangle, but assume that this is a square.
Yeah.
Okay, so that means all the sides, they are equal. So, and you have a circle. You have basically, you have a circle, okay, which is basically inside this square, right?
Yeah.
And this is S and this is C, right? So this is your center. So if you draw this line, what is this length of this line? Lines.
Diameter 2r.
Yeah, so basically this is diameter, right? So
This
if the radius is r,
Yeah.
okay, if the radius is r, then basically this diameter is 2r, right?
Correct.
And this is precisely the side of this square S, right? This is the length of the side of square S, right? Because
Yeah, correct.
this
Yes.
line is precisely the length of this line. The length of this line is precisely the length of this line, right? So,
Yeah.
so once you know one of the side of a square, then you can compute its area, right? So area of S1 is what? What is the
Square.
area of S1? Area of S1 is pi r square. Okay, so that is precisely pi times 4. Correct?
Yeah.
This is the area of the S1. So next thing is given that you have one more square S2, which is inside the circle C. Okay, so let me draw one more circle. Sorry, square.
One question here. You have taken diameter is 2r here, right?
Yeah, because the radius of the circle is what?
Correct. So area of S1 should be 4r square, isn't it?
4
R square.
Okay, sorry. Yeah, I sorry. I have used this area of circle. Okay, so basically this is 4r square. This is 2r times 2r. Yeah, correct. Right. So now this is my smaller square.
Correct.
S2. S2, right?
Yeah.
So, hello.
Yes, sir.
So the
Yes.
diagonal, we gotta take the diagonal.
Yeah. Correct. So basically, what you need to take now, you need to take the diagonal.
Okay.
Right?
Correct.
So now what you need to do? Can you see how you can get the
So it is x by, okay. So we know the diagonal and we try to find out the inner square
yeah.
side, right? So
Hmm.
it is sine 45 degree equal to x by m.
Mm,
Wait, I don't know what you
So
consider
it,
it.
so it could be like a root 2 is the diagonal. We can use that logic.
okay, so this is okay. So what is the length of this diagonal? What is the length of
It's 2r, right?
2r? Right?
Correct.
And this is alpha, right? This length of this is a square, right? S2 is also a square. So this length is alpha. This length is also alpha.
Correct.
Right?
Correct.
So
Yes.
now you can use Pythagoras theorem, right?
Hmm.
So alpha square plus alpha square is what?
2r square.
4
4r
r
square.
square.
2r square, right?
Yeah.
That means 2 alpha square is what? 4
4
R
r
square.
square.
So alpha is basically what?
R.
Root 2r, right?
Yes, sir.
Correct.
Yeah.
So now you know one of the length of one of the side of S2 as well, right?
Yes, yes.
So now you can compute the area of S2, right? So what will be the area of S2?
2r square.
2r square, right?
Yeah.
And area of S1 is basically 4r square, right?
Right.
So if you divide, then S1 basically S1 by S2 is 2 by 1, right?
We have to sum them.
Sorry.
We have to sum them. Find the value of m plus n.
So this is basically m by n, right? So m plus n is
Okay.
3. So as you can see, like it's basically given suppose the ratio of the area of the square S1 to the area of the square S2 is m is to n, right? So we are getting 2 is to 1, right? And as well as the GCD of 2 and 1, they are also GCD of 2 and 1 is 1. Okay, so this satisfies all the conditions. So now you just need to compute n plus n, which is 3. Clear, right?
Yes,
Yeah.
sir.
Hmm.
Yes, sir. I was out in the basic concept like how to predict the derivative value of what I mean. So I know the derivative behavior f prime of x. So how we tell the function is increasing at that particular interval f of x or decreasing at the particular interval based on f prime of x, that behavior. So that concept. So that actually the question.
I guess you were asking, let me take.
Sir, actually activity question 9.2, question number 9, it's related to that topic, sir.
9.2 question number 9, this one, right?
Yes, sir.
Yeah.
So increasing,
So-
decreasing.
So okay, so the thing is, there are actually 2 ways you can solve this question. Okay,
One
so
minute. Actually, this one is easy.
sorry.
Yes, sir. So actually, my basic doubt is their f of x is given, sir. So sorry, f prime of x is given. So they are the graph is shown. They are asking on that particular interval, f of x is increasing or decreasing, like that, sir.
Yeah, so I'll explain your doubt. So try to explain this by solving this question. Okay. So have you solved this question?
Yes, sir. I saw.
So what actually how you solve this question?
Could you see? Actually, they are given f of x. Then the question is, what are the true about f of x? So then easily I plot the function and I find
How you plotted this function?
okay, sir. So for this one, I will check that x1 is less than x2, then f of x1 is less than f of x2.
Okay, so that is sort of, yeah, that is.
But I have a little confusion on that, sir, because in that middle, maybe it's rising or.
I got your point. So okay, so let me solve this question. Okay, so again, like so you are asking slightly different, not different. Okay, so you are actually saying that how I can know the behavior of f of x by knowing the value of f dash of x, right?
Yes, sir.
Yeah, so the idea is very simple actually. If this f dash of x is greater than 0 for all x in my interval I, okay, that means f of x is increasing on I, right? And
Okay, sir.
so another thing is if dash of x is less than 0
Hmm.
for all x in I, that means f of x is decreasing on.
Decrease number. Okay.
So that actually you can check by the definition. Okay, these two things you can check by definition, the way we have defined.
Okay, sir.
So
If it's equal to 0, then we are no need. Then we are not saying this is increasing or decreasing because that's its saddle point, I think.
no, if
Not
certainly
turning.
if the derivative is 0, like for a in an interval,
Hmm.
okay, that means this interval is constant, right? So during that interval, the function is constant. When actually you will get the derivative to be 0?
Yes, sir. It's a constant.
Yeah.
It's constant.
So so basically if f dash of x is 0 for all x in I,
Then the
that
function
then
is
f of x
constant
is
function.
constant. Okay, it's
Yes, sir.
constant on. Because throughout all the points of the interval, if you draw the tangent, they're basically parallel to x-axis. So that is only possible when your graph will look like this. Okay, some line parallel to x-axis.
This should be second derivative, right?
No. This is first derivative. No, that is something different. So second derivative tells you the point of maxima and minimum. Okay.
Okay.
So the first derivative basically tells you the monotonicity of a function. Okay.
Okay.
If the first derivative is greater than 0, okay,
Mhm.
throughout this interval, okay, it's depend on the interval. So if first derivative is greater than 0, that means my original function is increasing on it. Okay. And if the first derivative is less than 0, that means my original function is decreasing on it. Okay, so just tell me why actually. So how you compute your limit at a point? Let's say
H tends to 0. That's definition are you asking, sir?
yeah, s tends to 0.
F of x plus h minus f of x divided by h.
Right?
Yes, sir.
So this is precisely your f dash of, right?
Yes, sir.
Suppose let me take this thing. Okay, first case. Suppose your f dash of a is greater than 0. Right? Suppose
Okay.
this is greater than 0. Right?
Okay.
So then whatever, suppose and so this limit is basically two things, right? It's left hand limit and right hand limit, right?
Yes. Yes, sir.
So let's say first we are trying to compute the left hand limit. S tends to 0 plus, right?
Okay, sir.
So that means a plus h is greater than a, right? Correct or not?
Yes, sir. A plus h is greater than a.
Because h is going towards 0 from the right hand side of x. Sorry, h is going towards 0 from the right hand side of 0. Right, that is what h tends to 0 plus means. So that means h is positive, right?
Yes, sir.
That means a plus h is greater than, right? If h is positive, then a plus h is certainly greater than a. Correct or not?
Yes, sir.
Yeah. So what actually now we are doing, we are computing f of a plus h minus f of a, okay, divided by h, right? This is a positive number, right?
Yes, sir.
This is a positive number, right? And if this thing becomes a negative number, okay, if this thing becomes a negative number, then the limit whatever you will get, this limit will be number which is less than or equal to 0, right?
Yes, sir.
If this is positive, if the denominator is positive, right? If the numerator becomes negative, okay, if the numerator becomes negative, then the final limit will be a number which is less than or
Less
equal
than or
to
equal
0.
to 0.
But our assumption is what? My derivative, that limit is greater than 0, right?
Yes, sir.
So for that, I have to, so for that, whatever I have written in the numerator, this has to be greater than 0. Okay, that means this has to be greater than 0. Okay. So in some sense, this function is increasing. That's why you can see a plus s is greater than f of.
Okay, sir.
So that is similarly, you can try the same logic.
0 minus.
0 minus. So in 0 minus, what you will have?
H is negative.
This is negative. Okay.
Yes, sir. Denominator is negative.
And also this a plus h is less than a,
Yes,
right?
then A. Yes, sir.
Correct or no? Because h is negative. So a plus s is less than, right? So your denominator is negative. And so to get a positive, so the condition is f dash a is greater than 0. Okay. So then the limit can be positive if and only the whatever I have written here in the numerator, this has to be also negative.
Negative.
Right. So that means f of a plus s minus f of a is negative.
Yes. Yes.
So that means my function is increasing. Okay, because a plus h is less than a, and what I am getting, f of a plus s is also less than f of, right?
Yes, sir.
So that's why this my function is increasing. So similarly, you can apply, you can do your proof for this case as well. Okay. So,
Okay.
so you got the idea,
Yeah.
right?
Yes, sir. Sir, consider a function y equal to x square.
Mhm.
So it's a basic function f of x equal to y equal to x square.
Hmm.
So they are asking the increasing and decreasing interval. So
Hmm.
negative infinity to 0, if the
Hmm.
function is decreasing,
Hmm.
and 0 to infinity, the function is increasing. That's clear, sir.
Hmm.
But I have a confusion in
Hmm.
the value of 0.
Hmm.
Which interval I will include, sir? That's my question. I will put open interval or closed interval for the decreasing interval or increasing interval. So,
You can put in any interval, it doesn't matter, right? So it's up to you, like it's up to you. See, if you take the derivative,
mm,
let's say f dash of x. What is f dash of x?
2x.
2x, right?
Yes, sir.
So if so in this interval 0 to, again I'm making same mistakes, so this should be minus infinity to 0, right?
Yes, sir.
So this function is, the derivative is negative, right?
Negative. Derivative is negative.
Negative. That means f is decreasing,
Decreasing.
as you can clearly see, right? This function, this graph is decreasing, right?
Yes, sir.
And similarly, f dash of x is if x is basically in this interval 0 to infinity,
0 to infinity.
this is positive, right?
Yes, sir.
That means this function is increasing. Okay. So again, like so the thing is, again, if you so certainly you cannot use this argument, derivative argument, okay, for 0, right?
Yes,
But
sir.
if you say that my function is decreasing in this interval minus infinity to 0, okay, that is also fine, right? This statement is correct, because certainly you are getting 0 at 0, you are getting 0.
Yes, sir.
So if you say that my function is decreasing on this interval, that is also fine. And if you say my function is increasing in this interval, that is also fine. It will not contradict anything. Okay. But certainly you can't use this derivative argument to tell this. Okay. Because this derivative is negative only on this open interval. Because if you once you include 0, then basically you are getting 0. Okay, which is certainly not negative. Clear or no?
Yes, sir. Yes, sir. Oh, for this derivative, we will use the f of x function. The question is given.
Hmm.
So from the given interval,
Hmm.
what the behavior of f prime of x? So we
Hmm.
will decide the function is decreasing or increasing, right, sir?
Yes, yes.
Okay, sir. Got it, sir. Clear.
And for particularly for this question, actually you can even you don't have to actually use this all these things. You simply you can do it even without using all these things. Okay. So let me do this question. So let's say this is my function, right? So my function is what? F of x is equals to x power 4 by 5, 3x power 4
By
by
2
2,
plus 11x cube by 3 minus 3x square.
3x square, right?
Yes, sir.
So this is my function. Okay, so I want to say like when this function is increasing or decreasing or whatever, like so.
Okay.
So first, let me try to find the what like basically the main idea is I want to find the turning points. Okay, so before that, let me try to find the critical. So first I need to find the critical points. And for that, what I have to do, I have to
So
compute the
f
derivative
prime of x equal to 0.
0, right?
Yes, sir.
So then what I will get, x power 4 12 by 6
6x cube
x cube
plus
plus
11x square minus 6x.
equal to 0, right?
Okay, sir.
So then I can take x out. Okay, so then basically what I will get, x cube minus 6x square
plus 11x
plus x
minus
minus 6 equals to 0. So let's say, okay, certainly, okay, it's more or less clear 0 is not a root of this equation, right? This one. Okay, so x cube minus 6x square plus 11 is 1. This is not 0 is, so now you substitute 1. What you are getting? 1
0.
0, right? So that means 1 is a root of
Yes,
this
sir.
equation.
1 is the root of the equation.
1, 2,
So
3.
yeah, so roots are 1, 2, 3 we're saying, right? Okay, so let me directly write x minus 1,
X minus 1, x minus
minus
2,
2,
minus 3.
x minus 3. Okay, so my critical points are so 1, 0,
2,
1,
3.
2, 3, because this will give me 0 because I have a factor. X is also a factor of f dash of x. Okay. So now let's compute f double dash of x. What is f double dash of x? F dash of x is this
4x cube
4x cube
minus 18x square
minus 18x square
plus 22x minus 6.
22x minus 6, right?
Yes, sir.
So now let's check what are these, what is the behavior of f of x at these points, right? At these points, what is the behavior of f of x? Whether these points are point of maxima or minima, or we can let apply the second derivative.
Okay.
So what is f dash of 0?
Negative 6.
Negative 6. That means 0 is a
Local maximum.
local
Maximum. Yes.
maximum, right?
Yes, sir.
And what about f dash of 1?
4 minus 18 plus 22 minus 6.
I don't.
12.
Okay, this is minus 4.
Yeah.
4 minus 18 plus 22
minus
minus 6. So yeah, so this is positive, right? This is
Yes.
26 minus 24. This is positive. Okay, that means 1 is a
local minimum.
local minimum, right? And what about f dash of 2.
It's also positive, I think.
No. See, this is local maxima. This is local minima. So then the next possible thing that can happen is local maxima. So this has to be
minus
negative.
2.
Yeah.
Okay, so your graph, so when you have a local maxima, see, when
Okay.
you have a local maxima, okay,
Hmm.
so then you can have a local minimum. Okay, again, then you can have a local maximum. Okay, so if your graph will go like this, okay, if your graph will keep on increasing, then after local minima, you will not get anything. Okay, so you can get a local minima after a local maxima. If you,
Okay, sir. Okay, got it, sir.
so your graph can be only like this. Look, you have a local minima. Sorry, this is a local minima. Then a maxima can occur. Then you have a minima. Then you have a maximum. Okay, so tell me what is f dash of 2?
-2.
-2, so local max.
Local maximum. And okay, f dash of 3 should be positive. Okay, so
Positive, so local.
Yeah. you can check this should be positive. So then you have local minima, right?
Yes.
Yes.
6.
So once I have all this information, then I can actually, so not exactly, but I can vaguely draw the graph of f of x. Okay. So I know 0 is a local maxima, right?
Hmm.
So then the graph of f of x at 0 should look like this, right?
Yes, sir.
Because this is a local maxima, right? Then f of 1 is a local minimum, right? So this is my 0. Then at 1, it should look like this, right?
Yes, sir.
So let's say this is my 1. Then in 2, I have a
Maxima.
maximum. In 2, I have a maximum. And similarly, 3, I have a local minimum. Okay. This is 3. So now I can tell, right, the behavior of f of x, right? So,
Yes, sir.
so during this interval, 0 to 1, my f of x is decreasing, right? And from 1 to 2,
It's
this is
increasing.
increasing, right? And
2 to 3
2 to 3, it's again
decreasing.
decreasing. Okay. So yeah, this is also another way of doing this problem. And certainly this is if you use this method, then certainly get this derivative.
I think there is another way of computing it very shortly.
Sorry, this one we are saying, right?
Yes, sir.
Yeah, this is easy.
By plotting the numbers in the number line.
Yeah. But again, to basically to get all these things, also you need to draw the graph of f dash of x, which is easy, right? So you know the tricks how to draw a polynomial, right? If you know the roots, then you can draw the polynomial. So this is your f dash of x. So it's
Just
pretty-
simply putting the values on the number line and plotting it according to the increasing degree.
Yeah, that also you can do. Okay. So this part is clear, right?
Yes, sir.
Yeah. Any other question you want me to discuss?
Sir, 9.1 7th question.
9.17 question. Okay, so this one, right?
Yes, sir.
So what is your doubt here? This is, I guess, easy. So okay, so before that, tell me how many turning points this curve has. This curve has in this interval, let's say in this interval 0 to infinity, because we have basically this graph is basically in this interval, right? 0 to pi. This is 0, this is pi. So how many
So
turning
one.
points? So this has one turning points, right?
Yes, sir.
This has also one turning, right? And probably this has how many turning points? One.
Only one.
Only one, right? And this has one. Okay, just a minute. Just a minute. This is 9.1. Let me see the graph whether they are matching or not. Yeah. So they are not matching. Yeah. So yeah. So this is probably the old file. Okay. If you see actually, if you see the graph in your assignment, this graph is slightly different.
Yes.
Yeah.
There's a valley in between two peaks. I mean, the curve 3
Three turning
in our
points.
assignments.
Yeah. So basically, if you see the
W shape.
graph is basically like this. You have this, then
Yes, sir.
like this, right?
Yes, it's just like
Yes,
that.
sir,
Yeah.
yes, exactly.
Yeah. So yeah. So basically, here if you see, you have three turning points, right?
Yes, sir.
1, 2, 3, and here you have 2, right? Okay. So now you know the number of turning points from the graph. Okay. Let me compute this for this function. So my function is f of x equal to, okay, what I have done. Yeah, so f of x is equal to sine x plus half sine 2x plus 1/3 sine 3. Okay, so f of x equal to sine x
Yes.
plus half sine 2x
Plus
plus 1/3
3 sine 3x.
3x, right?
Yes, sir.
So now you take the derivative.
Cos x
Cos x
plus cos 2x plus cos 3x.
cos 3x, right? So if you go back to the question, it's basically saying in hint, right? So differentiate the function and then use the formula this, right?
Yes, sir.
On what? Cos x and cos 3x, right?
Okay.
So now we'll do the same thing, right? We'll do the same thing for these two terms.
Okay.
So now if I apply, what I will get?
2 cos 4x by 2.
Cos x plus y by 2, that is basically cos 4x by 2, which is cos 2x.
2x into cos.
3x minus x by 2, right?
Yes, sir.
That is cos x
Cos x
plus cos
2x.
2x. So now you take
Cos 2x, the common term.
obvious choices. You need to take this as your common.
2 cos x plus 1.
2 cos x plus 1, right?
Yes, sir.
So again, whatever we are doing in this interval, right?
0 to pi.
0 to pi. Certainly you can't go beyond of this interval. So now I need to equate this with 0, right?
Yes, sir.
So from there I can get cos 2x equal to 0.
And 2 cos x plus 1 equal to 0.
To 0, right?
Yes, sir.
Yeah. So then from here, I need to find all the solution of cos 2x in this interval, 0 to pi, right?
Yes, sir.
So what are these solutions? if
So one would be pi by 2, another would be pi by 2, that is 3 pi by 2.
By 2 will give.
so that means if see cos 2x
Cos inverse
equal
of
to 0,
2.
that means 2x is pi by 2 and 3 pi by 2, right?
Yeah.
So
Pi by 4, right?
sorry,
Pi by 4 and 3 pi by 4.
yeah, so 2x
Acha, okay, yeah.
2x is
yeah.
pi by 2 and 3
Yeah.
pi by 2.
Okay.
So that means x is
5 by 4 and 3 pi by.
pi by 4, right? And so this is what we are getting by equating cos 2x equal to 0. So similarly, I can do the
Yes,
same
sir,
trick.
negative 1 by 2.
Mhm.
So
What will be the value of x?
So it will be pi by 2 plus pi, it will be 2 pi by 3, 2 pi by 3.
Correct, correct. So x equal to 2 pi by 3, right? Right. So now this is my, so these are the points that I am getting.
are the critical points.
These are the critical points, right? These
Yes,
are the critical. So now you try to compute f double dash of x.
So to find the local minima or maximum.
Local minima and local maximum. So once you compute, actually you can see that this is the obvious choice for this. This.
Okay, sir. Got it, sir. Clear.
So again, like you just need to compute f dash of x, and you need to substitute all these things to find out the local maximum and local minimum.
Sir, one question I want to ask.
Mhm.
Sir, if Riemann's left sum or right sum is not given, and the question answer is feeded according to Riemann's right sum, and I apply Riemann's left sum, then it will become wrong, no?
Sorry. If in the question it's asking about you to find the Riemann left sum and you are computing Riemann right sum.
No. If it is not given that compute Riemann's left sum or Riemann's right sum, then an answer is given according to right Riemann sum, and I am applying left Riemann sum, and it is not given that.
No. Certainly, if we'll ask this kind of question, then certainly we'll mention
that which Riemann I have to use.
Yes.
Okay.
So, otherwise, definitely you'll get grace mark. Okay. Any other thing you want me to discuss from activity? No more questions?
Sir, the practice assignment, sir. Whenever you're going to discuss the practice, I'll be asking the question.
So what is, from where? Just a minute.
The practice assignment, sir.
Have you checked the solution?
Sir, I just didn't understand that. That's why I'm just asking, just
fine.
to clarify, just clarifications. So it is the number 8 and 9. These two are related. So just one thing, like clearance to clear the other thing. So any one you choose, just give me the
8 and 9, right? Yeah.
Yes, this one.
Oh, okay. So this question. So so basically, a car manufacturer determines that in order to sell X number of cars, the price per car must be this. Okay. This is the price per car. And certainly with respect to this condition, when actually this car manufacturer is selling X number of cars and X is less than 800, then the price of each car must be this f of x equal to 100,000 minus x. And the manufacturer also determines that the total cost of producing X number of cars is this. If X is less than 400, then this
Less
is
than
the-
400.
Yeah. Okay, so that is basically the thing. So suppose the company can produce a maximum of 400 cars due to a production issue. Okay, and the number of cars the company should produce and sell in order to maximize the profit is what? So basically you need to company can produce a maximum 400 cars due to. Okay, so now you need to find the profit, right?
Yes, sir.
So basically, so then the general formula, the total income minus the total cost, right?
Yes, sir. Yes, sir.
So what is the so if it's producing X number of car, okay, then what will be the total income?
For one car, it would be 1,000 minus X. So it would be 2,000 minus X. That is clear, sir.
So this part is clear, right? And what is the
Yeah,
total
that part is clear.
total cost? So this is your total cost, right? The total cost. If
Yeah,
this
yeah,
is
yeah.
P, so this has two sections, right? If X is less than equal to 400, so this is your total
Yeah.
cost. And if X is
Yeah.
basically in between this, so then you have to subtract your G of X accordingly, right?
Mm-hmm.
Right?
Yeah, yeah.
So then this is your P of X, right? This is your total. This is your total profit, right?
Yeah.
Correct or not? And
Yes, sir. Yes, sir.
now it's fine, right? Because now there should not be any problem because
Sir, this is where I found the problem actually. So, sir, the thing is, in the question it said like produce a maximum of 400 cars. So if I take at most, so it is coming the first function. I mean the first one, that is the minus x squared plus 700x minus 30,000. That one, yeah, that one is clear. But that is kind of confusing because if it's strictly less than, or it could be equal to, like I couldn't understand that. So I don't know why they took that. So exactly what kind of like thinking I should have when I see such kind of abbreviations or something now, like maximum of 400 cards. So it is like at most.
Yeah,
like
at most.
it could
Yeah,
be
at most.
equal.
Yeah, yes. So when basically it's saying maximum of can produce maximum of 400 cards, that precisely is saying that X is basically less than equal to 400. Okay, maximum
Okay,
of
so
400.
okay.
Man, that means you can take 400, but certainly you can't take anything beyond that. Okay.
Okay, and I cannot take like 399 as well. So that is the locked value. Okay, got it. Got it.
Yeah, maximum of
So
400
that's-
means yeah.
I got it. So that's the point where I got stuck actually, like which function I have to take and something. And I didn't get the point, like why they took the first one. So that's why I did ask you. Okay, so got it. So thank you.
Okay, any other questions from activity or practice?
So just a minute. So I'm just trying to find another one. I think I had one.
Yeah, just let me know.
Okay, sir, I just found it. It's in the solve with us 9. It's not graded part, that one. So I got it right, but that, I mean, two options are not kind of similar. They are totally similar. And
Solve with
and
us,
I chose. Yeah. Question number 2 actually. The option third. No, sorry, not third. Fourth, right? Fourth, fifth, sixth. Yeah, fourth and sixth are actually, I mean, similar. So I got confused.
Solve
Like, I got it right.
Solve with us.
Question number 2, sir.
That regarding this critical points, right?
Yeah, sir. I mean, I got it right. The question I got it right, but the thing is, like, the two options are similar, so I got confused over there.
What's
the point?
Which one?
The fourth one and the sixth one. See, the observe that f-1 is 0. That option, like, is twice there. So what's like, why it is like that? I don't know. I don't understand that. I mean, what's this like? What is the point actually of that statement?
They're the same.
Yeah.
Yeah. It's basically same. So one, so we need to remove that option. So there, it's not that they're very like similar. They're precisely the same. Like whatever is written in option 4, the same thing is written in option 6 without any change. Okay. Yeah, it's basically.
So I totally got confused actually on that on those two options. Okay. I don't know what to do. So yeah.
Yeah, it's a mistake from our side. Like this is. You should remove that option.
Okay, sir. Sir, another one, sir. I mean, the next question. Just a general doubt. The next question is given in the second last option. It is like f of minus 50 less than f of 50. So which is actually true. So 50 cannot be the global minimum. So sir, in this case, like we have to calculate all the values just like we do in traditional way, right? So we have to actually calculate the values according to the options. I mean, not precisely for this question, like any kind of questions like this.
Okay, so since you asked this question, there is similar kind of question in activity. Let me solve this question. Okay. So
okay.
Yeah, this one, or whether they are same, I don't know. Probably they are same. Okay. X square plus 3. Yeah. So let me solve this question.
Screen share.
Oh, you can't.
It's frozen, I guess.
Fine, right? You can see my screen, right?
Yeah. Now it's fine, sir.
So basically, so here, as you can see, the function actually is defined. So in one part, it's defined on this interval, right? 0 to 50.
Yes,
and
sir.
Another part, it's defined from minus 50 to 0. Okay, so as you can see, when actually we are checking this local maxima and minima, or maybe say global maxima or minima, the most some tricky part is actually this endpoints. Okay, this endpoint. So here actually
the boundary points.
Yeah. So this boundary point. So 0. So the boundary points are basically 0, 50, and minus 50, right?
Minus 50, yeah.
So for that, actually, we need to check all the things separate. Okay. So first, what we need to do? We need to first find the critical points, right? By differentiating.
Like each differently. Each of the functions differently.
Correct. So if I differentiate the first part, okay. So then what I will get is basically 2x square plus x, right?
Plus.
Sorry,
2, sir.
2.
Minus 2x plus 2.
Yeah. Minus 2x plus 2.
Yeah. So the second one is basically 3x square, 3x square plus 3, right? Sorry, 0.
3x square plus 0, sir.
Yeah,
0.
yes.
3x square. 3x.
Yeah, so correct. So this is the derivative. So now if I equate this one, if I equate this to 0, what I will get? X equal to
1.
1, right? And if I equate this 3x square to 0,
0.
what
It is
X
0.
equal- but again, like
It is 0.
again, so as you can see, we don't have to consider this x equal to 0, because if you see actually we have defined this this thing in this given range, right?
Yes, sir. Yes, sir.
So, but in the given range, 0 is actually not a part of that range, right?
Yeah.
Correct,
For
correct
that
or-
for that interval. Yeah.
Yeah.
True.
So for that interval, actually we have defined this, right? X cube plus 3. Actually, in this interval, the value of the function is x cube plus 3, right? And 0 is not coming in this range, right? And when we are getting 0, then we have
Yes,
to
sir.
you have to avoid it, because 0 is not certainly
Yeah.
not in this part. Okay.
Mm-hmm.
So that means we have only one point, right? Only one critical point, right? Correct or not?
Yes, sir. Yes, sir. Yes, sir.
So
Just
now
one.
what actually I need to do? I need to compute the double derivative, right? So if I take the double derivative, what I will get? This
For
is
the first
basically
one is -2,
minus 2,
and for the second is 6x.
6x, and I need to find f double dash of
The double dash of 1.
1. So for that I have to use this part, right? The above one. Okay. So that is basically -2. So f double dash -1 is what? -2, right? Which is less than 0, right?
So it's a local maximum.
So this is a local
For
maximum,
now.
right?
Yeah.
So now, so the next thing is what you need to do. Next, we need to compute the endpoints, right? So the next
Yeah, the
thing what
function
you,
values.
yeah. So this is a local maxima, right? So then what will be the value? So then what will be f of -1? Sorry, f of I made mistake. This is f of 1, which is -2, which is less than 0. What will be the value of f of 1?
So it will be 5 minus 1. So 4.
This is -1, 4, right?
Yes.
And what is f of 0?
3.
Plus 3.
3, right? What is
Yeah.
f of 50?
This is a huge negative number.
Let's say this is okay. This is certainly huge, but it's not that huge that we can't compute. This is
Yes, so
-25.
we can compute that.
Yeah. So by hand we can. Okay. So this is 2500, and okay. So by hand, and also that we can compute easily. Okay. So this is
2397.
yeah. So minus
2397.
397, right? This is f of 50, right?
Yeah.
And what about f of -50?
Is a -50 whole cube plus 3.
This is basically,
The second function, sir. Like x cube plus 3, we need to take that.
yeah, basically it's minus
124997.
124,997, right? So as you can see, yeah. So as you can see, so now what we know, So only thing we know that 1 is a local maximum, right? That is the only thing we know. Correct or no?
Yes.
Yes, yes, sir.
So now we have computed all the values of the function at all the endpoints, right? F of 1 is equal to 4.
Yes, sir.
Okay, f of 1, certainly 1 is not a endpoint. So we have computed in the endpoints. F of 0 is equal to 3. F of 5 is equal to, f of 50 is equal to whatever. F of minus 50 is equal to whatever. Now, if you see f of 0 is certainly less than f of 1, right?
F of 1, yeah. Yes, sir. Yes, sir.
So that means 0 can't be a global maximum, right?
Global maximum, yeah.
0 can't be global maximum. Right. So now if you see this f of minus 50, okay, is strictly less than f of 50, right?
Yeah, that's true.
Correct or no? And
yes, sir. Yes, sir.
And also from our computation, we also didn't get any out of this critical point. We did not get any local minima, right? We did not get any local minimum. Correct or no? So that means
yes, sir.
This is actually the minimum value. Okay.
The global minimum.
This is the global minimum. Okay. So from your derivative, you always get bunch of local maxima and local minimum, right? And you try to compute the values of your function at these points with the values of the function at the end points. Okay. And you compare it, and using that you write your answer.
Right, sir.
Yeah.
Correct. Perfect.
Okay, fine. Okay, is there any other doubt?
So we can say 50 is a global maximum.
50?
F of 50 is a global maximum.
F of 50 is less than 0, right?
F of 50 is less than 0. So certainly f of 50 is less than f of 0, right?
Yeah.
So then it can't be a global maximum, right? So basically, if you see actually 1, in some sense, I guess 1 is your global maximum.
Yes, the 1 is the global maximum and minus 50 is the global minimum.
Global minimum. Okay, anything else?
Answer the same in the same section. Question number 10. I calculated the integral, the indefinite integral.
Solve with us or?
Yeah. Solve with us. But I found the correct answer, but the portal is saying it's wrong. Like each and every option I'm choosing, it is saying wrong. I don't know why.
Question number 10.
Yes, sir. The indefinite integral of e raised to 2x plus 2 raised to 3x plus 1 by 2x dx. That one.
Yeah, there is something wrong with this question. Like it's not even showing any answer.
Yes.
Yeah. Oh, okay. So that's a portal issue. Okay, got it. I thought I made some.
So you people are in discourse or not? Like
discussion forum, sir. We are in.
Sorry?
So we are in discussion forum, the Google groups.
Okay, Google group. Okay. So I don't know. I didn't get any mail regarding this. Okay. So whenever you are facing this issue, you can raise it over there. Okay. So we'll try to rectify it as soon as possible.
So, I didn't raise, sir, because I saw it like today before the session. So I was like, okay, we have a class, so I'm just gonna ask you. So I didn't raise that.
So basically, as far as from the today discussion, one thing is one mistake we found, that question number 2, I guess 2 options are basically same, and here also no answer is showing, right? Is there any other mistake which you want to? Okay. I'll certainly I'll inform the portal team to rectify these two things.
Oh, okay. Okay.
Yeah.
Thank you.
Yeah, thanks. Okay, then probably I'll stop the session now.
Thank you so much, sir.
Thanks. Yeah.
Thank you, sir.
Thank you all.
What is this?
Yeah, discourse. Okay, so once you probably will get discourse in the next semester. Okay, so few people must have discourse. Maybe most of you don't have discourse. Now you are actually using that Google forum. Okay, so maybe in next semester you will get a invitation from discourse. Okay. So discourse is in some sense is much more better than this Google forum. So here actually, so there actually you can write many things very easily. Like, so in Google forum, what is the issue that you can't write mathematical symbol? Okay, but in discourse actually you can clearly write all these things. This mathematical expression, whatever, you can write it clearly.
Okay.
Yeah. Probably once you officially get into this course, probably then you'll get an invitation from this course. Okay.
But we already enrolled, right?
Okay.
Yeah, probably I'm don't know. See, if you enroll, then certainly you will get soon. Okay.
Okay, thank you.
Yeah.
All right. Thank you, sir. Good night.
Yeah. Good night. Good night. Thanks.
Hello. Hello.